equipment. So this is the oldest and interesting way of drawing the schematic diagram. The second common way is we can draw the schematic circuit diagram by using computer software. And here computer software. And in this computer software, we are using what? The electronics simulators. Electronics simulators. For example, we can draw the circuit by using it means that you can draw the circuit by using Proteus. You are familiar with this. By using multitheam. If you are not familiar with this, then by using easy circuit, EDA, electronics drawing automation, okay, and also draw by free teething. Okay, we have another one that we call the free teething. Free teething. You can also draw by using KiCad. EDA, etc. So a schematic is circuit diagrams of your electronics design or electronics implementation. You can draw it by using a paper. Or you can draw it on the paper. So one of the working bench is paper. Right? Eh? One of our electronics drawing working bench is what? The paper. And the second one is computer software. But not only the computer software, but this by a computer software that we call them electronic simulator. Not every computer software can give us a chance to draw, but electronic simulators. And in these simulators, means electronic simulators should have a schematic editor. Some of the electronic simulators, first of all, we cannot call them simulators. Yes, once we call them simulators, means they have schematic editor. Right? Because simulator, it's a word derived from simulation. Are we together?
Yes. Question.
Welcome.
What is schematic editor? Schematic editor.
What do you mean of schematic editor?
Yes.
A schematic editor, it's a window in electronic simulators that can give you a chance to draw the schematic circuit, simulate, test, and edit. So schematic editor, simply we can say that it's just like a paper, but with more features. That in a paper you cannot do it.
So it means it is more precise.
Speak loudly.
It means it is more precisely to draw on those electronic simulators other than on paper, because in the simulators it gives you the chance to know if your circuit is functioning or it's working.
Okay, we are coming to that point. So she's asking a question that is it a perfect or is it a right way? I think that it's perfect to draw the circuit in computer in electronic simulator rather than on paper, because it can give you more interactive ways of testing or to check whether the circuit is working. Yeah, but also remember that drawing on paper is still a very interesting way or method that I insist you to do, because once you draw it on paper, mostly your mind is concentrating. I don't know what kind of the connection, but sometimes you find that your mind is concentrating to understand your design once you draw on paper rather than on electronic simulators. Because once you draw on paper, there's no any help. So your mind is really trying to work that once this signal has been processed, it has to come to this point. But if, for example, that in electronic simulator, whenever that you make any error, then the software assists to help you. So you may not even understand or keep your design in your mind. It's very simple to forget once you draw in the schematic rather than drawing on paper. But the disadvantage of drawing on paper, the limitations of paper, workbench, actually you cannot have access to test your design. Whether it's going to work or it won't be working. Right?
Yes.
But the rubber can help you to edit once you want to do some editing. But only the paper can help you to test your idea. And that's why we have to use both of these methods. Right?
Yes.
And here we have a note. So the first note is this one. So the schematic circuit diagram drawing or drawn, so schematic circuit diagram drawn on paper cannot be tested. Cannot be tested. Cannot be tested. Yes, cannot be tested. And that testing means that cannot be simulated. Cannot be simulated. Whether it's working or it's not working. The second note, the schematic diagram, circuit diagram, schematic circuit diagram, drawing on the schematic editors or EDA, automatic design automation, can be of what? Of electronics simulators can be tested. Can be tested or can be simulated. So you see the advantage of the first method over the second method. But in case of remembering your design, the first method is more effective rather than the second one. So then, my dear students, in this chapter 2, I will teach you about the electronics software benches and the electronics hardware benches. Electronics hardware benches. So in this chapter, I will just focus on benches. Electronic software benches and electronics hardware benches, which can help you to design or implement or drawing your circuit design and test them as well as you finish to check whether you get the desired result. So let us start with the first part. So this we call it A, which is electronics. Say electronics is software. Say electronic software working benches.
Electronic software working benches.
Yeah. Then just to pronounce them, somebody can see that you are crazy. But okay, tell them, so, okay, I'm crazy for this short time, but later on, they ask me the secret of my success. Again, say electronic software working benches.
Electronic software working benches.
Okay, so here we'll be focusing on some few terms, but let us start with the first term. This is 2.1, and the term is not new for most of you, especially except the beginners. And the term is the word simulation. Say simulation.
Simulation.
Say simulation.
Simulation.
Okay, ask yourself, just spend 30 seconds. Ask yourself, what is simulation? You heard this way. Do you know it? What is simulation? What's the meaning of it? Maybe you met with it once, you've been asked that you have to draw this circuit in Proteus and then simulate it. While yourself, you have never heard the word simulation, and then you've been given a task to simulate it. And for you, because you've been looking for the marks and thinking inside the box, you simulate it and submitted the result. But possibly you've never asked yourself about what is simulation. But today, you met with such kind of a question. It's simple, but it's expensive. It's simple if you have asked yourself. But if you have never asked yourself, then you find that nothing is simple in this world. So what is simulation? Ask yourself and try to ask your neighbor. Online students, you have to ask your neighbor if you are watching this video in a group. But if for these local students, ask your neighbor, what do you understand about simulation? And you have to ask her or him happily. My dear friend, what is simulation? What do you understand? What can you tell me about simulation? And once she's laughing, then imagine one day your son or your daughter is asking you that, Mother, did you learn electronics? Yeah. So what is simulation? How are you going to answer your kid that interesting question? Because you used to tell him or her, give him the certificate, and the continuous assessment, you used to give him or her how do you call it? The report, the school report. I was the first. Okay. We are the first. Mamu, help me. What is simulation? That is the starting point of learning electronic simulators. You have to know first the terminology. Simulation. What is it? You can know how to simulate, but you don't know what the meaning of simulation. So once you be given a task which is not already done, you cannot go further because you cannot think concerning about what you understand. Right? Right? Because you can know how to simulate, and especially you go online, you find different circuits which other people have designed, you take them, you just customize, and just edit a little bit, then the circuit is working. But that's not a responsibility of an engineer or a designer. You have to design, you have to think. But you'll be limited because if you find that you have a problem and nobody who has done anything else about that, you get stuck. Why? Because in your brain, you are always looking works that have been done by other people. Why? Because you don't know the meaning of the terminology, but you know how to take somebody's work and edit it and submit. Wow! So here is our question, our big question. And once you ask yourself, take a rough paper from tomorrow or from the next session. If you didn't prepare, we can come with rough paper because I want you to involve students in this course, this model, right? I want to involve you. And I have to teach you in method that we call active learning or student-centered learning. You remember that I mentioned how are you going to transfer us from what? From theoretical to the practical domain. You remember that somebody asked me that question. And I told you that I'll be using the method that called the student-centered learning system, where students is the main part of learning. So once you ask yourself right now, take your rough paper or maybe at the back of your exercise book, write what your friend has told you. I will give you 30 seconds. Just write it. Because I'm going to answer this question and we'll check about the thought of your friend. Don't ask him or her because you've asked him and they've been listening carefully about what he or she is saying. Just write. Whether it is wrong, whether it's correct, don't worry about that. We are not here because that we are perfect. We are here because we are learning. And in learning, doing mistakes, especially in exercise or in practice, is good rather than in working place. Okay, so I think that now we have written something even 2 ways or 3 ways. And that is the algorithm that we'll be following. I'm not here just to look for the definitions and come and entertain you. I want you to be involved about what you knew. So from there, you know that I don't know. So I have to receive the good news. Right? But if I be just giving you, say, I know this. This I know. This one. Okay? So what is simulation? What is simulation? What is simulation? So I found 3 definitions for you. You may choose one of them. You may like all the 3. But I found 3 so that you can have a wide chance of understanding. Are you ready for them?
Yes.
Receive them?
Yes.
Will you receive them with happiness?
Yes.
You have been good in simulating, yeah? So a simulation, say simulation.
Simulation.
Good. Simulation is the imitation. Say imitation.
Imitation.
Say imitation.
Imitation.
You know the meaning of imitation?
Yes.
What the meaning of it?
To copy.
To copy. Good try. Another student who can try. Of the real. Tattoo.
Yes.
What the meaning of imitation in Swahili? Or even in English you can explain what does it mean when you hear the word imitation?
For what I know,
It's
kuiga.
Kuiga.
Yes.
Okay, for what you know. So the first definition says a simulation is the imitation of the operation of the real world process or system over time. So listen carefully. So simulation is what? Is imitation. Say imitation.
Imitation.
That's just what you say. That means it's a representation of something, but visually. We have actual and visual. Say visual.
Visual.
Manake tuna actual, kitu chenyewe kama chenyewe, lakini pia tunaweza tukawakilisha kitu kwa mfano wake na kwa tabia yake, lakini kisiwepo chenyewe pale. For example, your mobile icons are not physical, are not actual. Hizi, eneo, ishtue kidogo. Atwende kwenye nani, hizi icon, kwa simu. Messaging, for example, this is stuff. These are visual. This is imitation. But they are not physically there. Hey, Hilda, have you ever think about that? These icons, for example, messaging icons, it's just imitation. And you know the imitations of what? Of an envelope. Before you were born in 1990, we who were born in 1990, 1980, and back then to 2000, and even less, rarely 2010, we used it to communicate by sending a letter. I have to write a letter to my friend who has been studying at Kilosa. I was studying at Kilangalanga Secondary School in Mlandizi, or when I was studying at Galano Secondary School in Tanga, I used to communicate with my primary schoolmate who has been a teacher of me, who has been my pre-Form 1 teacher up to Form 5 teacher, because he was 1 class ahead of me, and actually the guy also was very interested, he was gifted in teaching. So we used to communicate by writing letter. And you know that what the designer of the software or of the messaging has done, he just took the image or photo of the physical envelope. You have never think about that. You thought? You thought now when I've been explaining. Wonderful. But even now, congratulations, because others, they are still listening. They don't even want for them to be involved. Again, we have another icon, right? Another icon is phone, right? And what do you see in the phone? This is the oldest, the first landline telephone, right? The table telephone. It means that the wired telephone, the one that you see in the offices. So that is, but actually it's not there. It's imitation, right? But it can operate like the normal phone, because once you click, for example, once you click this icon, because I want you to understand, I'm just explaining to you in detail, because I want you to understand. Once you click it like this way, then you see the keypad. When you check the table phone, right, or the landline phone, it actually has what? A microphone and a speaker. But also it has what? A keypad. There is no display. You just dial the keypads, right? And then you listen on the speaker if it is ringing, right? Similarly, the same real world imitation, it has been presented here. Because once we click that icon, which is a visual, it's imitations of the physical or real world one, right? Then you see now you have a keypad of numbers and letters, because this is the smartphone right now. For that one also, I don't think, because you cannot write a message there. Because this is at a display, then you can write a message. But for that one, you cannot write a message, right? Yeah. So then now you put 07597453331. 07597453331. So my student did not save my number. But she called me 2 hours ago. Okay? Wonderful. So this is my number. So then you can make a call on first call or second call. But you see the same icon? It means that now, because once you finish there, actually you press a certain button, but sometimes you can return it down and then you listen again. Are we together?
Yes.
But actually, the TTCL, we who are using Tanzania, the TTCL, actually the table phones is not in this phone. This is visual. That's why once you remove the display, you will never see these icons physically. They are not there. Are we together?
Yes.
For that reason, with the same concept that I have explained to you in this smartphone, in electronic simulators, we are going to have a symbol of a resistor. Right? A symbol for it, a resistor. So you know the symbol of resistor is just like this way. But once I connect it, I can run the circuit. Once I can run the circuit, the main function of resistor, one of the functions of the resistor is to limit current, right? So then the programmers who are writing these electronic simulators, programs for these electronic simulators, which are at the back, then they used to know the equation, the mathematical equation of the resistor to limit current, and include it in the coding. So once I have this symbol for a resistor, which actually resistor is not there. It's imitation of the physical resistor. Once I simulate, this resistor will limit the current maybe from a battery which also is not there. So it can limit current. And the switch is not there, but you have its imitation. Then everything is imitation, but they work as a physical component. Hello? Hi. So now you see the advantage of applied mathematics. Because now in software, we don't need a lot of stories and color code. We just need a mathematical equation for a resistor to limit current. And we include in the code there. And they've been learning in C++, right?
Yes.
Yeah. But however, that you learned it for the purpose of passing what?
Exam.
and you told your parents, you know, what did you learn in this semester? Ah, my father, we learned programming. We learned programming. One day we'll write a program of M-Pesa. But you know, ma'am, in order for me to achieve that, there's a certain man who comes from somewhere, we don't know, and then he said that he will have a practical program. What do you think, ma'am, if I join with him? Ah, so it will be very interesting. Yeah, okay, fine. Then finally you met with somebody you have never expected to meet him. Okay, so this is the figure. So you see that, so you can have even a capacitor, you can have even a transistor. They are not there physically, but it's imitation. But you have been given a software or a setup of proteas, you have been simulating circuit, but you don't know what's going on. You might think, maybe you have thought that the resistor is there, the capacitor is there, or maybe you have thought that maybe the resistor which has been used is the one in the motherboard. No. The resistors which you are using on the schematic window, they are not the one that you